Mr. Apple that you're paying attention by saying hi to me in the chat.
Oh, yeah, say hello to Mr. Sprunger in the chat, folks.
If you're paying attention, and if you're not, then
Should we do more of those like Twitch streamer techniques of, press 1 in the chat if you agree?
Yeah.
Buddy.
Well, I've done stuff. I mean, I've done things.
Or get some, we need some sub-hype in the chat. Get the hype train going.
All about the hype train. But I've done things where I'm like, hey, if you're still paying attention, tell me your favorite movie or your favorite color or something like that.
Oh, that's good.
Yeah.
That's good.
And some of them do it, and some of them don't.
All right, and Denver.
Nobody
Well,
said hi to me yet, so
nobody did say hi.
I'm a little sad about
They're all technically here, but nobody seems to be like really truly present. That's sad.
It makes me sad that nobody.
They're sophomores though. They don't know you yet.
I can still at least say hi. They know how to say hi, but apparently Jasmine and Cynthia and Carlos and Adeline and Giselle and Denver and Ariel aren't here. They're not really paying attention.
Oh, did you hear that? He pronounced it correctly the first time. This guy's good. All right. All right, get out of here. I got class to teach. Good afternoon, everybody. Today we are going to explore the wonderful realm. That was a tongue twister. Wonderful realm. It's hard with the math. Of being wrong. Today is the day of logical fallacies. So we are going to wrap up our deductive reasoning and logic unit with the proper names for all of the mistakes that people have come to make when it comes to logic. And this is, well, yeah, we don't have time to cover all of them, unfortunately. But we'll focus on some of the big ones. And I want to start off by breaking these down categorically. And there's a large category that we are not covering, and that is the informal logical fallacies. We're going to deal with the formal structural logical fallacies for today. And I want to point out the difference. So if you think about this, a logical fallacy is any reasoning that is logically incorrect. Not anything that is just purely incorrect. It has to be logically incorrect. Okay, so we're only dealing with the logic part of any argument or conversation. Okay? They also want you to know here, all forms of human communication can contain fallacies. They can have errors. People are faulty, and when they communicate, they can break down in any number of ways. And if you studied argument in English class at all, you may remember the three types of arguments, the logos, ethos, and pathos. Right? We're just talking about logos here. Ethos and pathos, correctly or incorrectly used, does not apply. Okay? So when I say a logical fallacy, I'm already pushing aside any kind of appeal to emotion, right? Because that would be the ethos or pathos realm. We're not dealing with that. We're just talking about the logic part. How can you present a bad logical argument? It doesn't mean whoever's presenting the argument is necessarily wrong, right? That's actually got a name for it. That's the fallacy. That because they have a logical fallacy, the whole thing must be wrong. No. Just the guy presenting it did a bad job. Okay? And it doesn't mean you can't still convince someone even with an invalid argument. All right? So I want to set the bounds of what we're dealing with and what we're not dealing with here. Your homework this week on study.com takes a look at a lot of the informal fallacies. Right? And the informal ones have to do with the content, as they call here, the content, whoops, not presumption, content please, content or informal fallacies. And that is where you are saying, well, you tried to draw on this subject. One of them was, say, appeal to authority. Like, because this guy knows so much about the topic, he says this premise, therefore the conclusion must be true. That's an appeal to authority. That is not logically valid. The only things that are logically valid are those 4 laws of logic that we took a look at. Anything else is some type of fallacy. And so the 2 that we're going to take a look at today in class are the structural fallacies or the formal fallacies. And these are the ones that are misapplications of the 4 laws. So it's taking one of those and either using it wrong or reversing it, doing, oh, you used this one, but you did it backwards, and you got mixed up. Okay? Now, let me also say that the beauty of logical fallacies and knowing them is both 2 net positives, although one of them is a little rougher than the other. Let's put it that way. The one positive you can get out of this, why knowing logical fallacies can be useful and a benefit to you, is when dealing with somebody else and they present a logical argument, you can call them out on it. You're like, no, you're using a logical fallacy there. That is not a valid argument. You're incorrect, sir. And for some reason, humans get great pleasure in doing this. I don't know why. Like, for some, whatever reason, reading a perfectly good, valid, sound, beautiful argument is only mildly pleasant. Like, oh, that's good. Yeah, I agree with that. I follow. Okay, great. But it's way more exciting and way more fun when you get to point out that somebody else is wrong. No, you're wrong. You did it wrong. Here's why. I don't know why. People get a kick out of that. So, knowing these logical fallacies will allow you to do that. The other side of the coin, knowing these logical fallacies means you yourself are now responsible for not falling into them yourself, right? So now we're going to have some specific names for common mistakes students have been making in their logic homework all semester. You might be making all year, but now you'll know kind of with a focused study, hey, watch out for this. And you can identify that mistake and then erase it, change things before going on. Okay, I hope I've framed everything well enough. Are there any questions at this point? No? Questions on Zoom? All right, then here we go with solving quadratic equations. No, not, just kidding. That's the other class. Logical fallacies. We're going to focus on these 2, affirming the consequent and denying the antecedent. These are the 2, by far, the most common issues students have had because they deal with the wrong structure. Remember how I said all of these logic questions can be dealt with purely structurally. You do not need to know the content. You don't need to know anything about this character Gollum, and you don't even need to know what cake is. All you need to recognize is if a thing, then something else, right? We translate that into symbols, manipulate the symbols. That's the structure part. So these 2 fallacies are using the structure wrong. Here we go. Affirming the consequent. This logical fallacy is inferring the truth of the antecedent of an application from the truth of the consequent. Well, that's a wordy way to put it, isn't it? Okay, the antecedent is the first part. So in our classic, if P, then Q. Right? The antecedent would be P, the hypothesis. The consequent is the conclusion of the conditional, the Q. This one says, if I know that Q is true, then I'm also concluding, it must be that P was true as well. That's affirming the consequent. And it is not logically correct. Look at the example there. If it rains, then the game is canceled. That's pretty common for outdoor sporting events, right? We know the game has been canceled. does that necessarily mean it rained? To conclude what they're doing here, therefore it has rained, to conclude that is a logical fallacy of affirming the consequent. You assumed that that was the thing that happened because it caused the result. But raining is not the only way to cancel a sporting event. Right? Maybe nobody showed up. Maybe the umpire is late. Right? Who knows? There could be many other reasons for canceling it. This isn't the only one. It did not say only if it rains, the game will be canceled. Right? Another way to think about this fallacy is that affirming the consequent is assuming the converse. Oops. Converse is true. Remember, the converse statement was when you reverse the order. If Q, then P. If I had this statement, I could combine it with Q, modus ponens, conclude P. That'd be great. But you're assuming that this is true from only having the original conditional. That is not always the case. It could be. It's not like it's automatically false. As we said, with these logical fallacies, the presence of the fallacy does not mean the conclusion is false. It just means it's not guaranteed true by the logic. Okay? It's still up in the air. You need more information to determine it. Right? We would need more information to figure out if it really rained and caused the cancellation of the game or not. I'm sure there's somebody we could call, we could check the weather, right? There's ways of getting that information. But they assumed the converse was true. This is so common. People do this all the time. Not just students on their math homework, like everyday adults, okay? All the time. In the news media, especially. Oh gosh, you've heard about people talking about this, current events that, and somebody will say, oh, well, we saw that this happened. It must have been this thing, because we know that thing causes it. It's like, you don't know that's the only thing that causes it. Jeez. So watch out for this one. You turn on the TV at any hour of the day, go to the news program. I'm guaranteed you can find an instance of affirming the consequence. So common. So common. And now you get to call them out on their BS. Great fun. But, other side of the coin, watch out that you are not affirming the consequent. Okay? Lots of students made this mistake in their logic homework recently. Now you know what it looks like. Hey, wait. Did I match up the conclusion of my conditional? And I went backwards? Oh, I can't do that. That's a logical fallacy. All right. Questions on affirming the consequent? All right, the next one is very similar, denying the antecedent. So now we're doing the opposite and reversed again. So this is the logical fallacy of inferring the negation of the consequent as an implication from the negation of the antecedent. Okay, what does that mean? We still have our if P then Q. This is the consequent or the conclusion. This is the antecedent. We call them hypothesis. I apologize for the phrasing here. This is straight from Merriam-Webster. It was the shortest, simplest definitions I could find. But we're given this, and we're given not P. We are denying the antecedent. We're negating the first part, the hypothesis. If P, then Q, not P. And then someone comes along and says, oh, that means I can conclude, therefore, not Q, right? Wrong. That's a logical fallacy. You have denied the antecedent. Using the same example, if it rains, then the game is canceled. It has not rained. Therefore, the game is not canceled. Is that a safe assumption to make? just because the weather's nice, guarantees the game is in no way canceled. It's absolutely happening. You drive all the way out there. You've got your tickets ready. The sun is shining. The game is happening. Why is there nobody in the parking lot? This is kind of weird. Are you sure it's happening today? Well, they said if it rained, it would be canceled, and it's not raining. Okay? But yeah, but there's nobody here. There's no line. I don't even see the popcorn guy. Like, you head in, there's no game. It still got canceled anyway. How could that have happened? Who knows? There could be any number of reasons, as we mentioned before, right? It didn't say that's the only way to do it. So for the same reasoning, this is a logical fallacy once again. To deny the antecedent and conclude that that denies the consequent, well, no, don't automatically get that. Right? But people do this all the time. Another way to think about this one. Here we are assuming that the inverse is true. Oh, I said is twice. Right? The inverse is when you negate both statements, but you keep them in the same order. If I had that version, if I knew this was true, then yes, stating not P, then not Q, I could get that from following modus ponens. But I do not automatically get the inverse just because I have a conditional statement. That is not guaranteed true. The only alternative form to a conditional that is also always true is the contrapositive. You have to reverse the order and negate both sides. So if you were to somehow both affirm the consequent and deny the antecedent at the same time, I guess the two fallacies would undo each other and you'd be okay. It is strangely a two wrongs make a right kind of situation. But we see that in math all the time. We just don't like to use wrong and right. Right? Two negatives do make a positive. And three rights make a left. So, any questions on denying the antecedent? Okay. Then your task today is to go through these 10 arguments and identify which logical fallacy they have fallen for, if any. There are a couple thrown in here that are in fact valid arguments, in which case just write valid. Otherwise, all you need to do is say, hey, this guy is affirming the consequent or denying the antecedent. You can abbreviate them with AC and DA respectively. And I have taken all of these arguments, in fact, come from our homeworks and classworks from the previous weeks. So every time we had one of those, we said, hey, this was an invalid argument. Now we're going back and seeing exactly why was it invalid. Which fallacy did they succumb to? All right. Any questions on what we're doing? You don't have a Chromebook? Why not? You're supposed to come every day with your Chromebook charge. Mr. Sprunger, how could you? You have your phone? You have your phone? Really? I don't believe you. Luckily, that hasn't been too much of an issue this year. I think I had like one student one day, not that they didn't have it, it just didn't have battery power by the end of the day, and so they had to use their phone and tiny keyboard, but I guess they're used to that, so having fun. All right, one last reminder before I just leave you to work silently. Next week, end of the quarter, End of quarter test on Friday will be the online test. Next week, Wednesday, will be the written portion of the test. All color groups are required to attend. Okay? Even if it's not your assigned color day, tune in. It'll be all online. There'll be no in-person class that day. Attend online because it will be a timed portion. You have exactly that class time period to complete that portion of the test. Okay? If that would cause you a schedule conflict, you need to email me and we can set up an alternative time for you. Okay? To prepare for these assessments, this Friday I will be posting the review packet. And you will have the long weekend then to work on that. All right? With that reminder out of the way, I leave the rest of the time for you to work.